Hello there! We got a cool one for you today. We're going to be making these halftone patterns here in both Blender and Houdini. And really one of the big takeaways here is once you understand sort of the theory, the math, the algorithm behind what you're making, understanding the steps that you're trying to accomplish, it is easy in a way to jump between different software packages to accomplish certain effects. So that's what we're going to be looking at here. We'll start in Blender and then we'll jump over to Houdini. I'll put timestamps if you just want to skip to your specific software, but it's nice to compare and contrast and see how these are quite similar ways of going about this. That's it. Stick with me. All right, so let's start out here in Blender with Suzanne. And you can see here, this is essentially a post effect that's completely dynamic. I can rotate around the light and we get the rotating of the halftone pattern. And I'm starting off simple here with just black and white dots, and then we'll build up to a more CMYK style halftone pattern. And so this is very much a post effect, so everything's going to be happening in post or in the compositing mode for both programs, but you can see we can rotate around, everything's live in the viewport as long as we have our compositor always enabled. All right, so let's go ahead and look at this example. I'm going to just adjust the lighting a little bit. And let's think about the theory behind this. It's fun to play with, maybe something like that. So let's jump into the compositing mode right here and think about the theory of what we're trying to do. So essentially, we're emulating a halftone print. So we want larger dots where there is more shadow if we're just printing black, and smaller dots to no dots for the highlights here. And if we look at our original render here, here's our render, and we can see that roughly matches. Let's look at the monotone because we're dealing with monotone here. The halftone pattern is emulating these whites to blacks with the varying size of dots. And so really, if we try to put it into more of like an algorithmic way of saying it, we want the underlying value of our image to drive the size of this dot pattern that we're laying over the image. So once we kind of articulate it that way, I think it's easier to understand how you might build it. So we need a dot pattern and we need a luminance value to modulate the scale of that dot pattern. So let's make the dot pattern first. So very easy way of doing this is with a Verneuil texture. And I will say once we get to Houdini, they have a node that builds some of this together, but you could do it exactly the same way in Houdini too. So what we're doing here is we're using a Verneuil texture to make a dot pattern. So for those of you who don't know, if I just put down a Verneuil texture and let me not insert it into the chain there, hook it up to an image coordinates node, that just sets the scale to this 2D render aspect ratio, and we take a look at that. The Verneuil texture, Verneuil noise, is sometimes called cell noise, and you can see what this noise does is essentially it scatters a bunch of points, and the actual value of the pixels is representing the distance to the points. So it's like a little distance map depicted in value actually. So you can see right at the center it's black, we're right on top of the point, and as we get farther from the point it turns to white. White would be 1 furthest we get away from that center point. And if you turn off randomness to the Verneuil, it makes a perfect circular grid-like pattern. So that's what we're doing here, and I'm just adding a scale node and a rotate vector node, so then I'm able to actually scale that pattern. You could also use the scale on your Verneuil noise, but if you wanted to drive multiple noises with one scale, this is a nice way of doing it. You also have the rotation here, because when you do these halftone patterns, a lot of the times in reality, these patterns are rotated and offset a little bit, so they're not exactly aligned. And that's what makes those kind of rosettes or like circular patterns when you look at the CMYK example. But we're just doing monotone right now, so let's not even worry about that. So we have our dot pattern, and so we can use this scale to adjust the density of that pattern. So now what we need to do is have this dot pattern scale with an underlying luminosity of the image. And we can use a less than math function for that. So if I put down a math node, I can set this to less than and then plug in the distance. And let's just use this without even a... Okay, so let's look at this less than node a little closer here, just with the threshold float without even thinking about using an image to drive it. And you can see as soon as I plug in the Verneuil into this, we get this dot pattern. So what is actually happening under the hood here? Well, it's looking at every pixel here and it's comparing, is the value of that pixel less than 0.3? Well, if it is, that's true, so it'll make it white. So if we sort of flip back and forth here, let's set this to a really low value, 0.1, and we get really tiny white dots. If I look at my image, okay, yeah, only the very center, that black value of 0, is less than 0.1, so the dots will be really small. If I make this value 0.5, then it sets it right at that middle gray, so we have it right on the center of that gradient. If we set it all the way up to something like 0.9, almost everything in this is less than 0.9, so the whole image is almost turning white. So as a functional thing, you can use this to set the size of your dots. So your less than sets the size of the dots, and then your scale over here sets the overall repetition of that pattern, so how many total dots there are. So instead of using this threshold slider to drive the size of the dots, we can use our actual image or the luminance of our image. So if I go back down to this lower chain here, and I just realized, here's my camera. I'll keep it there. I'll keep my camera there. I'll pay attention so my camera doesn't cover up the nodes. Hopefully I wasn't covering up a bunch of nodes, but let me just show this top chain one more time, just in case. And now let's look at creating that image luminance. So I'm just using an RGB to black and white. We can look at the original render here. The color doesn't really matter because we're turning it to grayscale for this one. And then we want to invert it. So we basically want larger dots where these black lines are. So we use an invert color. So the brighter the luminance is saying make these dots bigger. I'm going to address this multiply node in a second. And then we plug that into the threshold of the less than. So I already have a threshold down here plugged in. So I just cut because as I was describing this, I realized I actually, in my original setup, did it the opposite way. I am plugging in the beauty image into the value and using the halftone dot pattern as the threshold, but really either way works. So it'll just be inverted. So if I plug in my beauty image into the threshold like I was describing, you see we get white dots. If I reverse these inputs, we get black dots. Same idea here. Hopefully that's not confusing. The theory remains the same. So the less than is what's controlling the size of the dots. All right, so going back here to the multiply, if we add a multiply to the image here, we can just have a global adjustment on the size of those dots. So the brighter the values overall will increase the size of the dots, the lower the value will decrease. So that's just a little functionality you can build in if you wanted to do an overall adjustment on all those dots, and we can still come in here and adjust the scale to get different halftone effects here. And so that's the black and white halftone pattern. I just input a little blur just to make it so like the ink bled a little bit into the page. That's optional. There's lots of little like analog-y, glitchy effects you could add on top of this, but that's the theory. That's how we're creating the halftone pattern with monotone. So let's look at how we can apply that to CMYK. Okay, this is like a cooking show. So I just opened a new prepped file so we can look at the CMYK halftone workflow. So now we're just expanding this into multiple channels instead of just black. So before we were like using a black and white printer. Now we want to emulate a CMYK cyan, magenta, yellow printing process. So really all we need to do is apply the same setup to each channel, RGB, and emulate that CMYK combination. So let's just look at what nodes I added to do that. I was experimenting with adding some extra stylistic nodes. I'm just gonna, I'll keep that there, but I was playing around here. So this is the render with a split toning effect on it, and we wanna apply that halftone pattern. So I gotta keep looking over so I don't cover up the nodes here. Let's take a look at that flow. So the one big thing we're doing differently is we're going to separate out each channel here. So if I preview this, we have the red channel, we invert it, I have the multiply just like before, and we have the same exact dot pattern with the less than and the blur. And then here's the main difference. Instead of just having it be black and white, we're remapping the red channel to cyan. So it's this sort of invert of what you would think. So if an image is really has a lot of red in it, we invert that. That means there's going to be mostly cyan printed in that area. So red becomes cyan, green becomes magenta, blue becomes yellow. You could artistically do this a lot of different ways, but I think that workflow makes sense here. And so we put a ramp right at the end of that whole chain. And instead of printing black, we change that black value to cyan. So that would be 0, 1, 1 for RGB. And keep in mind, it's kind of like you're thinking it subtractively, like you're printing, not additively. So you have a white sheet of paper, white remains white, and then black becomes cyan. And then we do the same thing for the other channels, and we'll just multiply them all together. So let's go ahead and just do that real fast. So we have this set up here. I'm going to take this whole set of nodes and go ahead and duplicate it, bring it down a bit. And we're going to, instead of using, we can use the same image coordinates for all of them. So I'm going to plug that into here. It doesn't really matter. Maybe for organization, I could keep it. But let's go ahead and plug in our green now to the color here. And instead of having a cyan at the end of the ramp here, we're going to have a magenta. So magenta is, I believe, 1, 0, 1. And we get that. And we can multiply our cyan and magenta. And now we have this. Cool. Let's do it one more time for our yellow. Duplicate, Shift D. Plug in our image coordinates for the noise, if I can freaking grab it, and plug in the blue value, in this case, for the color. And then on our ramp, I'll change this one to yellow. So we have 1, 1, 0. And I'll multiply that with our previous result. Plug in our last multiply and plug in the yellow. And there it is. So if I then look at the original result, we have it sort of like that. And then there's our halftone approximation of that. And a couple things we can do to make it a little bit nicer. We can rotate our patterns as I mentioned before. So maybe I do something like 75 for the blue channel, and let's do like 130 or something like that for the yellow. I'm getting the CMYK and RGB confused, but I'm just adding a unique rotation for both, and then we have that sort of offset now with each of those dots. We could add a black channel if we wanted to. We could take all of these and just run a minimum operation and then multiply that in as well. There's a lot of little like artistic tweaks you can do. Let's open my final version and take a look at that node tree. Oh, this alternate version was kind of cool. And it's fun to play with once you get that set up. So let's look at how this one, so here's the original render. I'm gonna just let that cook for a few seconds. I had it up to 4K, so this takes a little bit longer, and this is done in cycles instead of EV for this one. So let's go ahead and take a look at this, where I've added a few things. I was playing around with adding some hue and saturation, split toning, painterly filters before the halftone pattern, just to get some more interest. And then the other stuff you could experiment with, I could add a, let's see here, transform here and add a noise modifier to it. So as I scrub, we get a little bit of like boiling, like there's a little misalignment with the dots. So that could be an interesting touch you put into this. I mentioned you could have the black value as well, just to look at how you go about that. All I did here was I took, if we stretch this spaghetti web apart, we take each of those separate channels and then we just min them together. So use a minimum operation, and that gives you basically the darkest parts of the image. And then you can use that stylistically to create a just black halftone pattern and multiply that back over the whole thing. So if you wanted to kind of crunch your blacks with another black or CMYK pass, you could totally do it that way. There's lots of ways of going about that, but the theory behind it all is you're taking individual channels, you're applying that Verneuil noise and using the value of the image to modulate the size of your dots. You're multiplying it all together to recreate sort of a subtractive print process. And there you go. There you have it. Let's jump over to Houdini and look at how that process is very similar and slightly different, just based on some of the tools Houdini has. All right, so here we are in Houdini, and this is the very simple render that created that very poppy pop art pig. And you can see very similar workflow as Blender, actually. So if I click on this button, this button right here, I can select a composite, slap comp composite to apply to my render view. Very much the same as in Blender when you click on always show your compositor. So let's go ahead and do that. And then, wow, we get all this pop art applied. I can, scrub the timeline to move the render, move the pig head, rotate the pig head. I could rotate my camera, and all this updates dynamically here. The stars are screen space, so that might not always work out. So we have this post effect giving us this CMYK halftone print. I'm going to just go undo, and go back to my original camera angle here. And let's dive inside the COP network and see how things are different. So I'm not going to go over the Solaris stuff too much. Lots of other tutorials doing that. Focus mainly on this compositing of this halftone pattern. And I will give a shout out to Rohan Delvey, I think is how you say it. I'll link his stuff. He has lots of great stylistic compositing stuff in Houdini too. But let's go ahead and look at what we got in here. So I'm going to go ahead and click the plus sign and just switch into a composite view. So I can go viewer, composite view. And here we have a composite view very similar to Blender. All of these node-based compositing programs, we're sort of approaching nuke level, hopefully, within, a few months or maybe a year or something. But anywho, let's take a look at this. So we're using the slap comp block in Houdini so we can apply it live to the render. So you can just type slap comp block to get that. And then everything within this block will get applied to your actual rendered result. I'll go ahead and just undo that, put my display flag back at the end here. I went real saturated with this one. So let's look at the similarities and differences here. Very similar. You can see we have these three main strands here. I'm not going to recreate the monotone one just for brevity because it's basically the same. We have the three CMYK strands getting multiplied together. And I didn't even make like a black channel. I just used an outline effect and multiplied that over. So a little bit more of a stylistic treatment. Maybe you could think they like did black Sharpie over it or something like that. But let's look at how this is a little bit different. So I'm running some denoising on this image just to smooth it out. This stuff is just dealing with the star background, adding stars based on the Z depth. I'm going to ignore that for now. Let's look at the actual halftone pattern. So Houdini has a node called surface dither, which essentially is like doing the same thing we did in Blender with the Verneuil noise, but it's sort of all contained in one node. So it gives you a little bit more functionality, so you don't have to worry about creating some of those controls yourself. Same idea here though. We split the channels we want. So we do the red channel, invert it to get that negative, and then use that to control the dot scale in the dither pattern. And you can see there's some controls here to play around with. The pattern scale, very much like scaling the whole noise in Blender, so it's controlling the overall quantity of dots across the whole image. So you could mess with that to get smaller size, denser pattern, or bigger, more stylized dots. And then the dot scale here is basically specifying how much influence that dot scale input has over your image. So how much should this image scale those dots by? So very much how we were running that into the less than operation in Blender. Now we can just use this to control that. So if I set this to 0, we should be at all uniform dot sizes. So there's not really any impact from that dot scale input, or at least that's how I believe this is working. It's first time using this node, to be honest. But you can see as I up that, we get that varying dot scale. So really what to play with in this is your dot scale, your pattern scale. Density scale, I sort of just set it and forget it. to 0.65 in this case. And then ISO offset, very much like if you are familiar with Houdini and SDFs, you can use this as another way of shrinking or raising each individual dot. So it's very much doing the same as that less than operation. You can use this in conjunction with dot scale to shrink and enlarge your halftone dots. So you can kind of see how that's working as I slide it. So I'll just leave it somewhere around, where did I have it before? I had it at 0.98, so fairly large dots, and I'll leave it somewhere around here, let's say. So that surface dither's taking some of the brunt work of the less than Verneuil noise setup and just putting it into one node. And then I'm doing the same thing in the case of Houdini cops. I'm using a mono to RGB to do the same cyan ramp. And then I'm using transform 2Ds and blurs to get that same sort of jittery effect as in Blender. And then you can see same idea here. I can look at each of these. I have a magenta halftone pattern and a yellow halftone pattern. And I've linked these together, so if I adjust the surface dither here that I marked green, it will automatically adjust those surface dithers on these other channels. You can do that in Blender as well. I closed out Blender, but if you just right click and copy driver and then paste, that's basically the same as a relative reference in Houdini. So when you multiply all this together, you get this very flamboyant halftone pop art pig pattern. And just to touch on how I'm doing the outline, instead of using grease pencil functionality, which doesn't exist in Houdini, I'm using the edge detect normal node. So I can render a normal AOV here. So if I take a look at this block and just set it to normal by clicking down here, you can see in this little, I don't know why it didn't go to the viewport, but you can see here we can render the normal direction of our image here, and you can plug that into the edge detect normal input, and you can get a line art essentially of your scene, and you can adjust the scale and everything. And in my case, I just made that a black outline, so I just used a remap to adjust some of those values, flipped the ramp so it's black and white. And I did some other, just to briefly touch on, like experimental stuff where I'm using some of the new textures that Houdini has, like the grunge streaks, to start distorting the line art a little bit, just to add a little bit of irregularity to it. I also used these grunge leaks to multiply over the whole image, just sort of like little imperfections or dirt or grunge on top of everything. So these new grunge presets in Houdini are actually really nice. They can really speed up texturing, much more applicable to if you're thinking of using this as like Substance Designer, which I think at this point is pretty much possible and what I'm going to think about doing some more tutorials on. Where did my grunge go? There we go. So you got lots of cool kind of preset textures that are made for you here that would be very helpful when you're doing procedural texturing. All right, so we have the whoops, just click that to get rid of that checkerboard, even though now we're really getting into like our pop art pattern pig. Multiply that on top so you can see there's a little bit of that grunge texture. There's a little bit of distortion to the black outline. Multiply it on top of everything and you get that little added detail. And you could turn that into a halftone dot pattern. I just thought it might be nice to leave that one solid stylistically. And there you go. There's your pop art pig. So just to end it, this was just sort of spurred on by a desire to recreate the CMYK halftone sort of idea. And I thought that doing it in both software could illuminate similarities and differences. And at least with students I teach a lot of the time, there's a trepidation with switching between software packages, or there's like a lot of concern with what software package to learn first. It doesn't quite matter as long as you're really trying to understand the why behind what you're doing. So how this is functioning and not just clicking buttons willy-nilly to get a result, because then it'll be very hard for you to understand what you just did. And then if you do need to jump into a new software package, you won't be able to really understand what's going on. Houdini, I personally think, is great for kind of urging you to understand it and giving you ultimate control to do anything that you could desire to do. But Blender is a great piece of software as well. So hope to see you in future tutorials, and hopefully this doubles my viewership with the Blender and Houdini communities.